In 1940, a 67 km per hour wind began to twist and turn a 7,000-ton bridge, completely destroying it. Physics says standing waves were responsible for this. But what is a standing wave? Let's take an example. Suppose we shake a rope on one end. What we produce is a wave that moves forward. This is called a traveling wave. Traveling waves carry energy from one point, the source, to another point. But if two identical waves pass through each other in opposite directions, the crests and troughs lock together. The result no longer moves, it stands and vibrates, so we call it a standing wave. Now let's learn about nodes and antinodes. In a standing wave, there are certain points that do not move at all. These points are always at rest, and they are called nodes. On the other hand, we have certain points that oscillate with maximum amplitude. These are called as antinodes. Note that after each antinode, we have a node and vice versa. We can also have standing waves in two dimensions as is shown here. We have a circular drum that can vibrate in two different modes as is shown. Now we are at a position to answer the main question that we began with, the standing wave on the bridge. Let's have a look. We can clearly see a standing wave pattern has been generated on the bridge. This standing wave makes the bridge oscillate and therefore leads to its destruction. Now let's move on and learn more about standing waves. Let's learn about wavelength, amplitude, and frequency. The wavelength of a standing wave is the distance between two consecutive crests represented by letter lambda. The amplitude of a standing wave is the distance from the equilibrium position to the top of the crest represented by the letter A. The time period of a standing wave is the time it takes for an oscillation to start at the top, goes all the way to the bottom, and returns to its original position. This is called its time period, and it's related to the frequency by the equation F equals 1 over t, where frequency is simply the number of cycles a standing wave produces in 1 second. I have attached important questions which IB loves to ask in your finals in the description. I'll see you in the next one. Happy learning.